All right. Hey there, everybody. My name is Andy Zimmerman. I'm the Chief Technology Officer here at Grace Technologies. And I've been asked to come to you today unscripted to talk about our recent Bronze Award that we received from Plant Engineering's Product of the Year award setup, right? So that's for our new ControlGate product. But I thought before I talk specifically about our ControlGate product offerings, that I'd give you a little bit of a history lesson in terms of, where these products came from, what the demand is in the market for them, and just really what the whole product line can do, and why that ControlGate offering is seeing a lot of market traction right now. So to take you back a few years, we actually started building out industrial Internet of Things products really for some customers who were interested in monitoring current and temperature in their control panels. And that initial product design really led us to what we call a panel mount node, where we're able to install this type of system inside an industrial cabinet, and through the back of the panel, interface any sort of sensor or transducer that we might be interested in using. So for example, if you've got a vibration sensor or a temperature probe or a current clamp, whatever that is, we can bring that into the back of one of these devices, capture sensor data from it, push it up to the cloud, and use that data to either predict failures that have yet to occur, monitor historical data trends, send alerts or alarms when there's some data that's been collected that might be concerning, and just generally provide a fully featured Internet of Things based platform for our customers. So we saw a lot of early traction along those lines of monitoring current, monitoring temperature, providing that via the cloud. And in doing that, we started to see more and more desire for vibration monitoring in the plant environment. And that led us to kind of in the 2019 timeline, develop out what we call our vibration and temperature node. So this was actually a Plant Engineering Product of the Year award recipient last year. We developed this product in order to monitor triaxial acceleration and surface temperature on rotating equipment. And the idea there is to take this one step beyond monitoring things like temperature and current, and really looking at signs of degradation that can give you earlier indication of failure in specifically a rotating asset. So to just kind of walk you through that really quick, maybe the lowest hanging fruit on trying to detect failure in a motor or something else that spins is by just waiting until it fails, right? But most people at least will notice that something's wrong when it starts to make a lot of noise or have an elevated temperature. And even before that, we can use current measurements to give us, somewhat of an early indication that something's going wrong. When we deploy our vibration monitoring technology, we can actually get relatively, early indication that something is up in those rotating elements, and potentially provide, anywhere between a week and a month of early indication that a bearing needs to be changed out, or there's an alignment issue, whatever that problem is. So the vibration and temperature node has a couple of different iterations. We've recently launched our VBT2 product, which gives a little bit higher frequency signal that's targeted specifically at bearing issues. But we saw a lot of market traction kind of just behind the back of being able to monitor really anything we wanted with the panel mount node, and then really focusing on that vibration space with the vibration and temperature node. But our customers kind of, especially those that we've seen through our partnership with Rockwell, were really interested in seeing the data that we were capturing with these devices available to them, not only in the cloud, but also inside their existing control ecosystem, right? And that makes a lot of sense, because if you've already spent tens of millions of dollars in some case building up an ecosystem that is very heavily reliant on the PLC or a SCADA system, it just makes sense to be able to take any new data that your facility is capturing and make it available to those existing systems. So we went kind of back to work at the end of 2019 and developed a product that we've called our ControlGate. And the idea there is really that any data that comes from our existing technologies can be sent to one of these gateways. This is actually a combo gate, which has both a cloud component and a control component. But this allows us to capture data wirelessly from any number of vibration sensors, from, if you had some temperature or current monitoring devices distributed throughout your facility, we can bring those into that combo gate or that control gate, and we can then make that data available to your control system via just a standard Ethernet connection. So our current product offering in this space gives you really two different industrial protocols to work with, either Ethernet IP or Modbus TCP IP. Our roadmap there definitely has us expanding to other industrial protocols. So, if that is of interest, we certainly can kind of accelerate that product development for you. But in general, one of the big things that we needed to do in this case was create a system that would allow an integrator to easily make this control gate system work with a much larger installation. So the complexity there comes from the fact that in our typically networked scenario, you could have any number of vibration and temperature nodes or other panel mount devices that could be monitoring any number of different things. And we needed some way to make that available inside this singular device so that a PLC can grab at that data. And the way we did that is by creating a dynamic configurator of the memory map inside our control gate, making it really easy for someone using a typical Rockwell-based Studio 5000 approach, or any Modbus TCP IP-based analysis approach to get at whatever data they want to collect from a very comprehensive, unique and similar interface that we provide out of the control gate. And in many scenarios, it's also important to keep that data streaming up to the cloud. So the product line is developed kind of in three flavors. We have the straight control gate, which will take data from our wireless devices and make it available to you in the PLC. We have our cloud gate, which is kind of that legacy technology, which will take data from your wireless devices and make it available in our maintenance hub, which is our cloud user interface. Or you can go the other route and do what we call a combo gate, which gives you the best of both worlds. It allows you to get remote access via the web to the data that you're capturing and the insights that we can provide from the cloud. And it also lets you transition that data to your existing control systems, your data historians, whatever it is, using your standard Ethernet port on the back of the device. So, I think that's all I've got for you here. This was a little bit impromptu, but we really appreciate everybody that voted for our technology. We continue to encourage anybody who has questions about what we're doing or suggestions about what we can do better. Feel free to reach out to us. We'd love to chat with you, and we look forward to working with you in the future.